We're so indoctrinated in the millions of years, people are so indoctrinated in it, they just think it's true. It has to be true. And it's a view which makes no sense of the evidence.
The scientific evidence is suggesting that it can't be that old.
It can't be that old, it has to be young.
So really it's the integrity of the Bible and the integrity of God's character that are at stake.
Absolutely.
One of the common criticisms of young Earth creationists is you have no evidence. But actually, Don, you argue that there is a lot of evidence, and you've agreed to share 4 of those points with us today. Don, you've spoken about this internationally for almost 30 years. I wonder if you could share those 4 points with us.
Yeah, well, this is evidence for the young age of the Earth and the universe, and I actually have an article with 101 evidences on creation.com. But we're only dealing with 4 today. Number 1 is the soft tissues and proteins in fossils. Number 2 is carbon-14, which is a huge problem for the millions of years story. And number 3 is the amount of sediment formed in the millions of years scenario is not enough to create fossils, nowhere near enough. And the 4th evidence is the lack of stirring up of the sediments. It's called bioturbation, which is the effect of organisms in stirring it up. So they're the 4 ones we're dealing with today.
Okay, well, let's get started. Can you kick us off with soft tissue found in fossils?
So the first things found were by Dr. Mary Schweitzer in Montana in the United States in dinosaur bone, and this was world-shattering sort of discovery because no one expected this because of the belief in millions of years.
Okay.
So in 2005 she published about soft tissue in the form of flexible blood vessels. So that was what she published, and it caused rather a stir.
So what's the issue with finding things like blood vessels in dinosaur bones?
Well, they should have decayed away. They should not be there. So everybody expected these things, after the huge period of time that they put on them, would have become mineralised. So what happens is with fossils is that minerals percolate through the fossil and they replace all the organic matter. So there's no organic matter left, and certainly not flexible blood vessels. So this was world-shattering sort of claim.
Okay, so this was in 2005.
Yeah.
It's fairly recent.
Yes.
What's the oldest example that they have found so far?
Well, there's things other than dinosaurs, things supposedly much older than dinosaurs. For example, they found these marine worms with soft tissue in them, supposed to be 551 million years old is the claim.
Wow.
That's far older than any supposed dinosaur. So that's one. But also there's even porphyrins have been found at 1.1 billion years old.
All right. What are porphyrins?
Well, photosynthesis requires chlorophyll, and the core of the chlorophyll molecule, which is quite complex, is called porphyrin. It's quite a complex organic compound.
So it's an organic compound that's used in the photosynthesis process?
That's right, yeah. So blue-green algae have this in it. Well, all plants have this porphyrin as a core of chlorophyll.
Okay, so what is the significance of porphyrins being found in rock that is supposedly that old?
Well, they shouldn't be there, basically, because they should have well and truly decayed away and be nothing there. So one of the scientists commenting on this find, Dr. Jochen Brox, and I'll quote, "I was just awestruck that these molecules can survive for such a long time."
Wow.
But they should be questioning the time frame, because we know they can't last for that period of time. And there are ones that are dated even older, but we can just deal with these.
Okay, so we have organic compounds found in dinosaur bones dated to be millions of years old. And then we have porphyrins found in rock dated to be billions of years old. How do we know that those organic compounds, those porphyrins, can't actually last that long?
Well, you can do laboratory studies on various compounds like proteins and different things, it's DNA, RNA. You can do laboratory studies where you basically heat the things at various temperatures, so a whole range of temperatures, and then you monitor how quickly they decay or break down. And so you get a mathematical curve, which is well known and well established, been known for a long, long time, that chemical reactions speed up with temperature. And so once you get that curve, you can then predict back to normal temperatures like 0 or 10 or something like that degrees Celsius in the rocks, assuming some sort of history that they would have been subjected to, and you can calculate then the decay rate at that temperature. And you can also do these studies in the presence of oxygen or absence of oxygen, presence of water, the absence of water, and you can get this relationship between temperature and how long they last. So this is well-established science that these compounds can't last for millions of years.
Okay, so in the lab we can test and we can get almost a formula that we can then apply.
We get a formula, actual formula, yeah.
Okay, so we get a formula that we can apply to real-world situations and work out how long they could last. Yeah. And you're saying they couldn't last millions or billions of years?
They can't. They just can't last millions of years.
Okay. How do those who believe that these dinosaur bones and this shale rock are that old explain that?
Well, they have rescue devices. And the first rescue device, when Dr. Mary Schweitzer published on the flexible blood vessels and the red blood cells, was to say that the flexible blood vessels were actually produced by bacteria, which had invaded the bones and had produced biofilms. The bacterial biofilms have created this flexible, recently, obviously, very recently. So that was rather convenient that it happened very recently. So Dr. Mary Schweitzer then said, well, I don't really agree with that. I think it's actual dinosaur material. So she went back to the lab and she found evidence for proteins in the dinosaur bones. And the proteins she found were proteins that are only produced by vertebrates. They're not produced by bacteria. So that squashed that one.
Okay.
The bacterial biofilms doesn't work. Second rescue device was the idea, and this is Dr. Mary Schweitzer herself suggested this, that the hemoglobin from red blood, acts as some sort of preservative. That the heme or the iron from it acts as some sort of preservative. And she did there were no studies done, like I was talking about a while ago, with the elevated temperature to actually work out whether that's feasible or not. But this suggestion was made and people latched onto that. Oh, there we understand now why the dinosaur, blah, 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 blah. But, the blood bank that deals with blood and blood donations would like to know that blood preserves things because it lasts a few weeks under refrigeration.
Yeah.
But also, if this was true, then you'd find evidence of the hemoglobin or the iron, evenly through the fossils. And it's not, of course, because the blood's associated with the blood vessels and things. It's not uniformly through fossils. So it doesn't really explain, it can't explain the persistence of these things. And the third rescue device, which is slightly more recent, is what's called toast idea.
Okay.
Toast, yeah.
What does that mean?
So when you cook your toast for breakfast, the heat actually causes cross-linking between the sugars and things and the starch and so on. That's what causes it to go brown. They suggested that the fossils, this toasting thing could happen, that the sugars and things could cross-link and they could form some sort of protection to make it last longer.
Okay.
But of course, does toast last millions of years?
No. Okay.
So again, there's been no actual studies with elevated temperatures and so on in a lab to show that this actually could possibly preserve things. So there's a grasping at straws, really, that this toast thing could do it. And you've got things like the racemization of amino acids, for example, which is where the amino acids become both left and right-handed over time. And that's something that's well known and has got a temperature relationship, and how would toasting stop that, and etc. So it's really grasping at straws, and there's such a number of these discoveries being made now across the whole spectrum of time that they're really grasping at straws with these sorts of ideas.
So basically, the scientific evidence is suggesting that it can't be that old.
It can't be that old. It has to be young, yeah.
So it's consistent with a young Earth.
Consistent with a young Earth, yes.
Okay.
Doesn't prove a young Earth. Nothing proves an old Earth either.
Yeah.
But it doesn't prove it, but it's consistent with it, yeah.
All right. Let's move on to your next point. I think you mentioned carbon-14. Can you talk to me about that?
So we probably need to explain what it is for a start. So carbon-14 is the radioactive form of carbon, which, because it breaks down or decays in a fairly predictable manner, it's been used for dating of things, particularly things that were once living, because plants take up carbon dioxide, and some of the carbon dioxide has carbon-14, the radioactive element, instead of the normal carbon-12, which is not radioactive, so it has some of the radioactive element. And so you and I have both got some carbon-14 in us.
Okay.
And while ever we're eating food, which comes from plants, which have taken in the CO2, so they've got some of this in it. The animals that eat the plants, us, or if we eat an animal that's eaten the plants, we get the carbon-14 in us, so we're slightly radioactive. But when you die, you stop eating. Mm-hmm. So then there's carbon-14 decays, and so you can actually use it to date things.
Okay, so it's something that every living thing consumes, but once we stop living, it exits our system, would you say?
Yeah, so it then starts to decay.
Okay.
Well, you're not replacing it, so it then decays, and you can do based on the amount of carbon-14 present when you look at it, you can estimate when it was living.
Okay.
So that's how it works, and it's useful in archaeology and so on. But the problem is you have to calibrate it some way or other, and once you go past known archaeological dates, it becomes quite iffy, woolly as to how you calibrate it. You know, they've got ways that they claim it work, but I doubt them.
Okay, so how does carbon-14 act as an evidence for a young Earth?
Well, carbon-14 has a very short half-life compared to many radioactive elements. It's got a half-life of 5,730 years. You say, well, that sounds like a long time.
It does.
But it's compared to the billions of years of some isotopes, like uranium and thorium and things like that. It's quite short. So consequently, every 5,730 years, half it disappears. And it doesn't take too much mathematics to work out that something which was, say, even 100,000 years old could have no carbon-14 present because it's all decayed away. Because, you can actually make the point that if the whole Earth were carbon-14 and nothing else, in 1 million years there'd be nothing left. So that just illustrates how quickly it breaks down. Yep. Now, of course, nothing was ever 100% carbon-14. It's only a tiny percentage. So consequently, the realistic figure is certainly 100,000 years you could have no carbon-14 present.
All right. So could you give me a few examples of where we found carbon-14 somewhere that it shouldn't be?
Well, we can first of all look at some examples of where they've dated, say, the rocks using one dating technique as millions of years old. So this is sort of a firm date in the evolutionary way of thinking, where they've also found organic material like wood. And then we thought, well, we can date the wood using carbon-14. Do they agree? Or there shouldn't be any carbon-14 there if the other date's correct. So there's two we can mention. There's many of these, but two of them. One of them is in Crinum Mine in Western Queensland, and the company had a drill core which they put down to survey the coal for the mine, and they had reported they found in a basalt layer, which is volcanic rock, hot molten rock, inside the basalt they found some wood, and the wood had been charred. So we thought that'd be interesting to actually get a carbon date in the wood. Now, no evolutionary geologist would even dream of doing that because they'd think there's nothing there, there's nothing to find. We say, no, we don't believe the age because the basalt's supposed to be, tens of millions of years old. Okay. We don't believe that age. We believe that happened during Noah's flood 4,500 years ago. So consequently, there could be carbon-14 in the wood. So we managed to get samples of both the basalt and the wood, and Dr. Andrew Snelling, a geologist, was working for our ministry at the time, sent these off to standard labs that do the dating, and they dated the basalt as tens of millions of years old with potassium argon dating, and they found carbon-14 in the wood, which shouldn't be there if the basalt's actually that old.
So do we know that the wood was placed there at the same time as the basalt?
Well, yes, and because actually the wood's charred. So it's charred because it was exposed to the heat of the molten basalt, so they have to be the same age.
Okay, so it was burnt by the volcanic.
Yeah. So it wasn't a root that grew down into it afterwards. I mean, the basalt's cold at that stage. So we know that the wood was the same age as the basalt.
All right. I think you mentioned a second instance.
Yeah, so there's another one where the Sydney Sandstone, for example, is supposed to be 230 million years old in the evolutionary deep time sort of way of thinking. And again, there was a report of some wood being found encased in the sandstone. So we thought, well, that's interesting. Again, we thought the sandstone formed in Noah's flood, and there's quite a bit of evidence that's the case. But so we thought, the sandstone formed in Noah's flood 4,500 years ago. The wood would be that age, so we would expect again to find carbon-14 in the wood. So again, we got the sample of wood off to the radiometric dating laboratory, and it came back with, again, had carbon-14 in it. Shouldn't be there if the 230 million years is correct. So again, it's consistent with the biblical time frame and the concept that this was formed during Noah's flood.
So I want to get to your third point of the rate of sedimentation in just a minute. Firstly, is there anything else that carbon-14 can tell us?
Oh yes, there's much. So we find right across the Phanerozoic. The Phanerozoic is the part of the geologic column which has fossils in it.
Okay.
Right? It's supposed to be 541 million years time frame. This is what the time frame they put on it. But you find that right across that spectrum, you find fossils with carbon-14 in them.
Inside the layer of rock, which is meant to be 500 million years.
Right through. From the current right through to 541. There's stuff all the way through which has carbon-14 in it, like coal and marble and wood and all sorts of things, shells and things. They have carbon-14 in them right through the whole Phanerozoic. And none of these things that are dated as millions of years or even hundreds of millions of years old, none of them should have any carbon-14, but they've all got a similar amount of carbon-14 even. And that's consistent with all that stuff being buried during Noah's flood.
So from an evolutionary perspective, you would expect to see decreasing levels
well,
of
you'd expect
carbon-14.
to find that none of the things that are dated as more than 100,000 years old should have any carbon-14 in them.
Okay.
And yet all these things dated millions, tens of millions, hundreds of millions of years, all of them have carbon-14, and they all have a similar amount of carbon-14. How can that be? So it's consistent with all that stuff being buried in the global flood of Noah.
So could that be due to contamination? Could the carbon-14 somehow have got further down into the rock?
Recently, it has to be within 50,000 years. So some magic process put carbon-14 right through the geologic column, the whole Phanerozoic, the same amount, recently. How? They try to argue contamination, but the process of dating using carbon-14, there's a check for that, and it's called the carbon-13, carbon-12 ratio. It's a check whether the material comes from an organic source or whether it's contamination, like for atmospheric carbon dioxide gets into it or something like that. So, no, that's checked for in the process of carbon dating, so that's not an answer. I mean, another attempt to answer it is that uranium decay can generate carbon-14, but to get that amount of carbon-14 with uranium decay, you'd have something 99% uranium. It wouldn't be an organic thing.
And we don't see uranium?
Well, no, there's no evidence of any significant quantity of uranium in these things. Certainly not enough to explain the carbon-14.
So just before we jump into your third point, a quick recap. Your first point was?
Fragile organic compounds in fossils that are millions of years old, and those fragile organic compounds shouldn't be there if they're at that age.
Okay, and your second point?
Carbon-14. So carbon-14 shouldn't be there if things are millions of years old, and it's consistently there.
All right, and now your third.
And the third point is the fact there are fossils means something about the age of things. Because to make a fossil, you have to bury it in sediment or in mud. because things that die in the bush somewhere, so if a horse dies out in the paddock or in the bush, it doesn't last very long. Within months it's disintegrated, it's been eaten by scavengers and it's spread all over the place, and within a short time it's all gone. In fact, you find not just horses but even whales standing on their tails in the fossil record. You find tree trunks penetrating many layers, all sorts of things which indicate they had to be buried quickly. But even just ordinary small things have to be buried to be reserved as well. So you need a lot of mud to actually make fossils. And the things, the Phanerozoic, that section of the geologic column which has got full of fossils, they have a time frame of 541 million years. You say, well, how thick is it? It's about 2 kilometres thick on average. So just get your calculator out and divide 2 kilometres by 541 million years, and how much mud do you get? 0.004 millimetres per year.
That's quite small.
That's like a 25th the thickness of a sheet of paper in a year.
That's the layer of mud.
That's on average how much mud, sand, silt, clay being deposited according to the deep time scenario of the formation of the Phanerozoic over 541 million years.
That's hardly anything.
It's
over
nothing.
A year.
You don't get any fossils with that amount of stuff.
Yeah, like you say, I mean, if a bird died at the roadside, you wouldn't just see it slowly be buried. It disappears. So how do they reconcile
Well, they
this?
don't. They can't. And there are some geologists just quietly have admitted the problem, but it's not shouted from the rooftops, is it?
No.
It's out of whack by orders of magnitude. An order of magnitude is 10, and this is so far out of kilter with reality. It's like hundreds of thousands out of kilter with reality. To form fossils, you need lots of mud, and a 25th the thickness of a sheet of paper per year is not going to preserve anything.
So how do we actually know how much mud is needed and how quickly it is needed to be deposited for a fossil to form? Can we know that?
For a start, they need to be buried. I mean, there's nothing can be preserved as a fossil if it's not buried. And how do you bury something with a 25th of a sheet of paper in a year? You know, I mean, like it's just right out of kilter. But also the fossils, you find many of the fossils are actually preserved with incredible detail, like fish with all the scales and everything. So the thing, I mean, if a fish is dead for a week even, it's decaying and falling apart. So, but you find them with all their scales and everything intact, and again, the biomolecules, like the things, proteins and all this sort of stuff to preserve. I mean, dinosaurs have been found with their scales, and you found a horse all complete, all the bones are all connected together.
Oh.
And the whale on its tail is actually intact. It's not bits and pieces spread around the countryside. Trees that penetrate through many layers. I mean, a tree doesn't stand there. If you think of that amount of material each year, how long would it take to bury a tree?
Ages.
Right.
It takes so long.
And you have trees standing there with their roots broken off.
Yeah.
How do they stand up while they're being buried at, 0.004 millimetres of material a year? So there's been experiments done with small crocodiles, so little ones.
Yeah.
And they buried them in mud to see how much mud you had to put on top of them to hold them down, because what happens is things die, gases form inside, and then they float.
Yes.
And then they're floating, and then things eat them and they disintegrate. So how much mud? And they found you needed at least 20 centimetres, about that much mud on these little tiny crocodiles. You needed about that much mud to hold them down so they didn't pop out and float, and then they disintegrate. So and we talk about 20 centimetres like now, not over 100,000 years. The whole 0.004 millimetres a year. I mean, they could argue that, there was twice as much material and half it's eroded away. That makes it 0.008 millimetres. It doesn't help much. So I don't see a rescue device for this. It's very clear that the millions of years is just fiction.
So we've had soft tissue, carbon-14, the rate of sedimentation. What is your fourth point for us today?
So the fourth point relates to the rate of sedimentation, and that is called bioturbation.
Okay, what's that?
So bioturbation is the stirring up of sediment that happens. Like if you go to the beach, I don't know whether you've ever been someone fishing and you get pippies,
Yeah.
little shellfish, like about that big. You can eat them or you can use them for bait. And you put your toes into the sand and you dig them out. And if you're not quick, they burrow back into the sand, right? They're gone. You've got to do it again. So those sorts of things have been around since the beginning of the Phanerozoic. In other words, the Cambrian, right 541 million years, the fossil record shows that sort of creature's been there all along with the worms and other things that stir up. I mean, beach worms, another thing is for fishermen. They burrow into the sand.
Yeah.
So how quickly does that happen? They found that within hours, these creatures stir it up to 10 centimetres depth. So just within hours, they stir it up. So here's the problem for the millions of years story. In the Phanerozoic, these creatures are present all the way through, stirring things up, and yet there's layering just about all the way through, almost all the way through the Phanerozoic, there's layering. And that layering shouldn't be there.
Is that because the creatures should have stirred and blurred the lines?
Stirred and blurred the lines.
Okay.
All the lines should be blurred and gone because of the stirring.
Okay.
But the lines are there.
Where do we see the lines today?
Well, you can see it in any where you see a cutting, for example, where they've done a road cutting through a hill.
Yeah.
You can see the layers. You see it in the Grand Canyon, very clearly, and you see all this structure in the rock, which shouldn't be there if it was laid down at 0.004 millimetres a year. I mean, you need to stop these creatures from stirring it up, you need to bury them deep enough to kill them.
Yeah.
And you actually find that the fossils of these things are actually intact. Like the shells are still, they're like that. The bivalves. Now, when they die, the muscle that holds them together lets the shells come apart. So when you go to the beach, you find all these shells lying around, but the living ones are like that. And when you find the fossils, they're like that. They've been buried and killed in the process.
So they've been buried alive.
Buried alive, that's right. And they can't get out. So how much stuff do you need to dump on top of them to stop them from actually stirring it up? Actually, they can't get out, so they can't stir it up. You need tens of centimetres of stuff to dump on top of them straight away, not over a long period of time. If you do it a little bit each day even, they're going to just stir it up.
Yeah.
So the 0.004 is out of kilter by, if you think about just 10 centimetres of material, you're talking something like 25,000 times an error.
Wow.
This is the millions of years story. And, it's not just me saying this. There's actually geologists. I quote from Bromley, 1990, is a standard secular geologist. He said, I'll quote from him. He says, 100% bioturbation, that is a total stirring up of everything.
Yeah.
A total 100% bioturbation of the substrate is the natural end product of the activity of the endobenthos, that's the burrowers.
Okay.
Failure to reach 100% or failure of that state to be preserved in the rock record are conditions that require explanation.
So they're basically saying, we're not sure.
Don't know, have no idea. Because there's no way they can explain this when they believe in the millions of years. So it's a mystery because they've got the millions of years stuck in their head. It must be true because everybody knows it's true. But it's true. It just says it's wrong. It's so far out of kilter with reality. But we're so indoctrinated in the millions of years. People are so indoctrinated in it. They just think it's true. It has to be true. It's like when you start talking about things being young or thousands of years, that's just bizarre to so many people because they've been so indoctrinated in this view, and it's a view which makes no sense of the evidence.
So you think the reason that perhaps people aren't taking what would seem to you the most obvious conclusion from this evidence is because they have stuck in their minds the idea of a long age of the Earth?
It's inconceivable in their thinking it could be wrong because everybody knows it's right, don't we? We don't stick a rock in a machine and measure its age. It's easy. No, you don't. You can't do that.
Okay, so I get that soft tissue, carbon-14, rate of sedimentation and bioturbation are all fairly persuasive evidences for a young Earth. But why is this important?
Well, it's important because people think they've been so brainwashed with the millions of years. When they start reading the Bible, they say, "Oh, I can't believe this." So that's a first thing. It's important because people think they can't believe the Bible because of this stuff. But on top of that, you have, unfortunately, some theologians, for example, who seem to think that this is something they have to accept and they've got to make that fit with the Bible. And then they start trying to change the Bible to make it fit the millions of years story. And how do they do that? You see, they've got hundreds of millions of years of fossils, and the fossils are a record of death, disease and suffering. In fact, you even find cancer in fossils, tumours and things, So this is not a benign death of these animals and things. It's a cruel death, and that's what's recorded in the fossil record. And so these theologians who've been hoodwinked by the geologists into thinking they have to accept the millions of years, so, well, where can we fit millions of years into the Bible, And they've dreamt up all sorts of schemes to do that, and there's probably about 15 different schemes, and there's 15 because none of them work. The days are long periods of time is probably the most common go-to.
Yeah, I've heard that. I've heard that the days when the Bible says it was one day, the second day, the third day, that these weren't 24-hour days. What's your response to that?
Yeah, well, the Bible's clear that each one has an evening and morning, and there's 6 days with a seventh day of rest, the base of our 7-day week. I mean, it's plain as day what day means, but people, I can't believe it because of millions of years. So, but in doing that, in fitting all that, where do they fit all that millions of years in? They've got to have it before Adam and Eve. So in other words, Adam and Eve in the Garden of Eden were standing on a pile of bones miles deep.
Yes.
Or kilometres deep. So that means that God created a world of death and suffering. It also means that death and suffering were here before sin, before Adam sinned, which undermines the gospel. And then we have there's going to be new heavens and new earth in the future where things are going to be restored. What restored back to millions of years of death and suffering? I mean, it undermines everything if you think about it. So that's why it's important. It's actually much more important than biological evolution is the age of things. Because it puts death, suffering and disease before sin and makes God into an ugly God who created death, suffering and disease.
So really it's the integrity of the Bible and the integrity of God's character that are at stake.
Absolutely, yeah.
Well, thank you, Don. This has been so informative. If people wanted to find out more about evidence for the age of a young Earth, where could they go?
Well, there's a major article with 101 evidences, and you can go to creation.com, and it's a very simple URL, which is creation.com/age. Cool. And thank you, Bronte.
Thank you.